Hello everyone. So today we would be starting climatology and the first topic is atmosphere. Now here looking into that how the atmosphere evolved. The first point is removal of the pre-existing atmosphere due to the solar winds. As we know that Earth receives solar radiations today also. But hardly one radiation out of billion radiations received on Earth's surface are absorbed by Earth. But going to the beginning when Earth was just evolving, at that time Earth's atmosphere consists of various harmful and toxic gases. But for sustaining life on the Earth's surface, these harmful gases has to be removed. At that time, the solar winds played a very important role in the removal of those harmful gases from the surface of Earth. As the solar radiation would come on the Earth's surface, those radiations would not be repelled by the Earth that much strongly because the magnetic field of the Earth was not evolved at that time. So that's why these solar radiations takes away the harmful gases from the surface of the Earth, thereby helps in sustaining the lives of various species on the surface of Earth. The second point here is volcanic eruption and resultant degassing due to meteors. Meteors also played a very important role in the evolution of atmosphere. Meteors falling on the Earth's surface made craters. Meteors, when falling on the Earth's surface, they made these craters. And these craters helps in releasing the pressure of the Earth's surface. Let's say this is the Earth, and this pressure is released. If this pressure is released, means degassing has occurred. Due to the release of the pressure from this part of the earth, it helps to release various harmful gases, water vapor, CO2, and all other gases also. So this helps to release the gases from here. As the meteors have made crater here, this crater helps to release the gases from this surface. So as water vapor also come outside this, water vapor lead to the formation of clouds here and further condensation occurred due to which rainfall have led to the formation of hydrosphere at the time. What was happened is when the rain falls at that time, the CO2 get mixed in it. So by the addition of CO2 into the rainwater, it lead to further cool temperature in the atmosphere, and this cool temperature further lead to the cycle of rainfall for a very long time. For millions of years the rainfall continuously occurred, and this much rainfall lead to the creation of oceans on the surface of earth. So this process has occurred due to the meteors. Meteors falls on the Earth's surface, formed craters. Craters have made release of the pressure. Due to the pressure release, water vapor, CO2 and other harmful gases released. Condensation occurred, clouds formed, CO2 mixed with the cloud water and lead to the cold temperatures, and this cycle goes on. This lead to the formation of hydrosphere, or we can call it oceans. The next one is photosynthesis in the oceans. In the beginning, the photosynthesis has occurred in the oceans only. So in the beginning, when some atoms were there in the oceans, there were some of the atoms over there in the oceans, which lead to the formation of further complex atoms. So some atoms lead to the formation of other complex atoms, which further lead to the formation of some species. And the best part is these species can do photosynthesis. So photosynthesis first occurred in the oceans. So those kind of animals or species evolved in the oceans which can do photosynthesis, and due to which some oxygen started to show their presence in the oceans. So oxygen firstly occurred in the oceans only. So the entire ocean after millions of years get flooded with the oxygen only. So if it has some capacity and it is already flooded with the oxygen completely, then this oxygen started to get come out. This oxygen is started to get come out and release into the atmosphere. So now the atmosphere of Earth also have some oxygen gas. This is what we have today. So hence, if the oxygen is also present outside the ocean boundary, then animals can also start to move to the land, because now land can also avail you the oxygen from the atmosphere. So that's why animals presence also shown on the land also. This is how the atmosphere formed on the surface of earth. First of all, harmful gases removed, then the cooling of the earth. After the cooling, the oceans formed, and oceans also lead to the collection of oxygen. Oxygen get transferred to the atmosphere on the surface of earth, and which further lead to life possible on the surface of earth. Next, looking into the composition of the atmosphere. So the atmosphere consists of various gases, particulate matter, dust, water vapor. So looking into the gases first of all, the first one and the very important one is nitrogen. Nitrogen is formed on the Earth's surface by the weathering of the igneous rocks, very important one, or by the nitrification processes, as we know in the nitrogen cycle. And nitrogen plays a very important role. That is, it helps to maintain the oxygen, because oxygen is of very reactive nature, combustible nature of oxygen. It helps to maintain that nature. The next one is oxygen. So oxygen, we can get it from green plants and by the respiration process, by the photosynthesis process. And the next is it is necessary for all living beings on the earth's surface. The next one is CO2, and this CO2 we can get it as from the degassing of the earth's surface, as we have seen previously, and from the respiration process, by the burning of fuels also. And CO2 is released when the melting of the glaciers take place. CO2 is released from the decaying of the organic matter, and CO2 plays a very important role in for the green plants in photosynthesis. It helps in maintaining the temperature of the earth, acting as a greenhouse gas. It acts as a very important greenhouse gas. Next one is we have particulate matter on the atmosphere. How this particulate matter plays a very important role is, in the rainfall to occur, rainfall needs some surface to get condensed. It means that before the condensation to take place, water needs a surface where it will get condensed. So if there is a dust particle, on that water can easily get condensed. This is how the hygroscopic nuclei would form, and all the water would get collected on that surface. So that's why particulate matter and the dust plays important role. As we have heard about the drops got collected on the car's surface, because if there is a dust particle on the surface of the car, water can easily get condensed on that surface. So this condensation would only take place if there is some surface would be provided to it. So these particulate matter and dust also have some important role in this rainfall to occur. So, and the next one is we have water vapor in the atmosphere. That is obviously important for the rainfall, and it helps in the reflection of light and various other light phenomena. That's how the composition of atmosphere is. Now, looking at the structure of the atmosphere, we have four major layers. The first one is troposphere, stratosphere, mesosphere, thermosphere. Starting with troposphere. Troposphere is that one where we can observe various phenomena, and those phenomena are rainfall or the cloud formation, fogs, all such activities. As we can see here, clouds. Airplanes also can be observed in the troposphere. This is a line, as we can see in this line, this is temperature and altitude on the vertical line. As the altitude is increasing, temperature is decreasing in the troposphere. So, in case of troposphere, the temperature would be decreasing with the altitude. And one more thing, that the equators receive more direct insolation, or the tropics also receives more insolation of the sun compared to the poles. That's why more insolation means more heat would be there, and if more heated, then it would be expanding more. So expansion would be directly related to the heat it has. That's why on the earth we would see that the height of the troposphere would not be same for everything. In case of poles, it is just 8 kilometers. But in case of the equator, it is 18 kilometers, because the part which is more heated would expand more. As the poles are less heated, they would expand less. So that's why the height of the troposphere would vary from poles to the equator. As this is the tropopause point, this tropopause point would be different for the equator of the earth and the poles of the earth based on the heat it has. The first one is troposphere. Temperature would be decreasing with increase in altitude, and tropopause for the equator is around 18 kilometers from the surface of earth, and for the poles it is 8 kilometers. The next layer is stratosphere, and the stratosphere is the layer where we can see ozone, and due to the presence of ozone, it can increase the temperature. As ozone can increase the temperature, we can see that there is an increase in temperature in the stratosphere. The next is mesosphere, and we can see mesosphere temperature is decreasing with increase in altitude. Mesosphere is the coldest one because the temperature would not be decreasing more than this. This is the lowest temperature we can find. So mesosphere is the coldest one. And mesosphere protects the earth from the meteors and asteroids before they are reaching onto the earth's surface. The next one is thermosphere, and thermosphere is the layer in which we can see that the temperature is increasing with the increase in altitude, and it also has ions which helps the earth to protect it from various radiations. So this is how there are various layers, and on the variation of altitude, how the temperature of these layers varies. So this is the structure of the atmosphere. I hope you understand the topic well. Thank you for watching.